Yeah, I couldn't say there's a best rack, if that's what you're asking. I can tell you that the best way to prevent a collapse from a seismic event would be to have a design of a rack that is made to withstand these forces. And basically, in our design codes, we have these factors that we have to take into account. And so when you buy a rack, it needs to be designed for where you're going to use it, in what circumstances, what type of soil you have under that slab at that location specifically, and what type of pallets we're putting in, what mass is going to be in there, because all these factors affect the seismic behavior, the dynamic behavior of the rack system. So we can't just buy a rack system, I would say, anymore, in the sense that you know, the rack design code made its way to the building code in 2012. Before that, you know, racks were like, yeah, it's, you buy something at IKEA, you don't need an engineer's stamp on it, right? But not anymore. You know, these are serious structures. Imagine, for example, a 2,500 pound pallet, you have two on a pair of beams. That's 5,000 pounds. Well, that's close to having a Ford F-150 in each on each pair of beams. So when you walk down the aisle, imagine yourself that, you know, you have all these struts overhanging slightly on top of your head, and you have 5 beam levels of those. Would you trust not to have something that is designed for that purpose? Of course not. So yeah, so the best way to prevent a collapse in the seismic zone is to have a rack that is designed for that purpose. And mind you, there's plenty of racks that have sustained seismic activity. In Mexico, a very strong earthquake that hit, and some racks were fine, some others maybe less. But the racks that were designed for seismic activity were fine.